Hello there, and welcome back to the Sleepy Explorer, your quiet little spacecraft at the edge of the night, where questions don't need fast answers and wonder drifts as slowly as starlight. Tonight, we're not staying close to home. Instead, we'll let our minds hitch a ride on something mysterious, an object from far, far away, known only by a dry little label, 3I Atlas. Astronomers call it an interstellar visitor, but some dreamers, and even a few curious scientists, have wondered if it could be something more. Not just a wandering rock, but a vessel, a kind of frozen ark carrying the seeds of life itself. Don't worry, this isn't the sort of alien talk that keeps you awake with flashing UFO lights. Think of it instead like a story whispered on a long train ride, where each turn of the track is another possibility. Science, myth, speculation, and those delightfully odd ideas that might have fallen out of a half-forgotten sci-fi paperback. Before we begin, I'd love to know where you're listening from tonight. Are you wrapped in a blanket with your phone glowing softly in the dark? Or maybe sitting by a window where the night air still holds the scent of summer? Share your place and your local time. If you'd like it, always feels magical, knowing how far this little community of sleepy travellers really reaches. And of course, if drifting through ideas like this brings you calm, feel free to give this video a like or subscribe, but only if it feels right for you. That way, this small ship of quiet curiosity can keep finding new companions out in the digital night. So, let's set a slow course now, leaving behind the noise of the day, and turn our gaze toward a traveller from the stars, a visitor that may, just maybe, carry the story of life itself. You picture yourself lying back, your breath steady, as the story unfolds. Somewhere, across the silent gulf of space, an object slips quietly into the realm of our Sunday. It doesn't belong here, its path is too sharp, its velocity too high. Most comets and asteroids are children of our solar system, bound to its gravity like family members at a long reunion. But this one is a stranger, cutting across the gathering like someone stepping in from another street entirely. Its name, at least the one astronomers gave it, is 3I Atlas, the third interstellar object ever confirmed. Before it, there was Oumuamua in 2017, a cigar-shaped enigma that tumbled past Earth, leaving debates in its wake. After that came 2I Borisov, a more familiar comet that hissed and glowed like the icy wanderers we already knew. And now, this third arrival, less famous, yet no less intriguing. Scientists spotted it thanks to the Asteroid Terrestrial Impact Last Alert System, ATLAS, a mouthful of a project meant to catch dangerous objects heading our way. Ironically, what it caught was not danger, but mystery. 3I Atlas was streaking through space with a trajectory that made one thing certain. It came from elsewhere. You imagine the scene at an observatory. Late-night coffee cups, a researcher blinking at the screen, noticing the orbital math just doesn't fit. A little like realizing the quiet guest at your party doesn't appear in any of your family photos. Where did you come from? The astronomers must have wondered. The thought alone is enough to stir something dreamy. After all, it means we live in a universe where visitors arrive unannounced. Travellers from distances so immense you can't even pronounce the numbers without your tongue feeling tired. And 3I Atlas is one such traveller crossing the void, now gliding past our neighbourhood like a bird that has flown oceans without stopping. But the question whispers at the edges of your mind. Is it truly just a bird, or could it be a message in disguise? You let your mind drift further, following this silent traveller as though you were riding alongside it. Imagine clinging to its frozen surface, the stars sweeping by in dizzying silence, the sun shrinking behind it, then swelling again as it approaches our system. You'd feel no vibration, no hum of an engine, just the faint tremor of space dust pinging against its flanks, each grain colliding after untold centuries in the void. Astronomers measured its speed, fast enough that it could never be bound to the sun's gravity. Like Oumuamua before it, this visitor would never loop back for another orbit. It was a passerby, a tourist who doesn't buy return tickets. That fact alone is sobering. We get these encounters only once. A brief glance, a snapshot in time, before the traveller fades into the dark again. The mainstream fact, the one you could jot down in a science notebook, is that interstellar objects like this confirm our galaxy is far from empty. The gaps between stars are not barren deserts but highways, with debris and fragments constantly drifting. Each one might be a shard chipped off from planetary birth, or a relic flung out by gravitational chaos. In that sense, 3i Atlas is a postcard from some other star system, the one we may never visit, but from which a piece has stumbled into our yard. And yet, your imagination resists leaving it there, because there is the quirky tidbit whispered on the fringes of astronomy, the idea that some interstellar objects could be deliberate messengers, that civilizations, long gone or still alive, might have launched objects like this on purpose, not for communication by radio, but by biology. Instead of words, they send cells. Instead of letters, they send seeds. Scientists still argue whether panspermia, the idea that life can leap between worlds, is credible. Some call it fringe, some treat it seriously enough to publish entire papers. After all, microbes on Earth have proven shockingly resilient. They can survive in boiling hot vents, in Antarctic ice, even inside the radiation-soaked shell of a spacecraft. Why not tucked away inside a lump of rock, shielded from cosmic rays drifting for millions of years? You picture 3i Atlas again, this time not as a dead chunk, but as a container. Maybe its cracks glow faintly in your mind's eye, hinting at something stirring inside. Not machinery, not blinking lights, just the possibility of something small, fragile and patient. A cargo that doesn't need fuel or navigation, just time. And suddenly the thought lands, perhaps you and every listener tonight are children of a similar seed. Perhaps Earth itself was seeded long ago by a cousin of this visitor, some other ark that spilled its spores onto a newborn world of oceans and storms. If that is true, then watching 3i Atlas drift by feels less like observing a stranger and more like recognizing an ancestor. You let that possibility hang in the air like the faint chime of wind through a half-open window, a rock carrying the memory of a civilization, or at least the spark of biology. Not in a dramatic way, not like the silver saucers of pulp magazines, but in the quietest, most understated sense. A seed doesn't shout, it waits. It trusts the soil and the seasons, and in the same way, maybe 3i Atlas trusts the stars to do the work, carrying it where it needs to go, until one day it finds a home. Imagine the patience. This traveller may have wandered for eons, longer than all of human history, longer than the rise and fall of continents. It could have left its birth star when Earth itself was still molten and unfriendly, and now, only now, does it brush past us like a stranger crossing a street. The sheer timescales press gently on your chest, reminding you how small a human lifetime is and how vast a journey the cosmos can sustain. A mainstream astronomer might shrug and say, it is simply an icy fragment, broken loose from a comet belt around another star, thrown outward during a planetary shuffle. And that explanation is elegant in its own way, but your mind drifts, as minds do in the late hours, towards softer questions. What if the shuffle was intentional? What if someone, somewhere, once decided to turn natural comets into couriers? There are whispers in scientific history about panspermia as more than just an accident. The Nobel Prize-winning biologist Francis Crick, co-discoverer of DNA's structure, once entertained the thought that life might have been seeded deliberately, a concept called directed panspermia. He didn't claim it was true, only that it could not be ruled out, and that alone is enough to make the night feel a little less certain and a little more enchanted. The fringe idea flickers into your imagination, a seed ship, looking indistinguishable from an asteroid, travelling light years to scatter its genetic stowaways on fertile worlds, a cosmic gardener sowing in darkness, never waiting for thanks. If such gardeners exist, you might wonder, do they ever check on their gardens? Or do they scatter and move on, leaving us to grow wild on our own? Scientists still argue whether such a thing is remotely plausible, but late at night, plausibility matters less than possibility. So you lie there, thinking of 3i Atlas slipping past unseen by most of the world, a quiet stone to some, a vessel of hope to others. Its presence is both utterly ordinary and profoundly strange. A lump of ice and dust, yes, and perhaps, at the same time, a cradle carrying the future of life. And as you drift with that thought, The boundaries between science and story blur, because in the gentle quiet of night, you don't need a telescope to feel awe. You only need the willingness to wonder whether the next stranger in our sky is just passing through, or whether it carries within it the very recipe of existence. You let the vision of Three-Eye Atlas linger as it glides silently out of sight, and your thoughts begin to follow a different thread. If such a visitor could carry seeds, what would that mean for us? The idea is not as new as it feels. In fact, it is almost as old as philosophy itself. Long before telescopes, long before rockets and satellites, thinkers in the ancient world were already whispering about life drifting between the stars. The Greek philosopher Anaxagoras, nearly 2,500 years ago, spoke of seeds of all things scattered throughout the cosmos. He imagined that everything, from trees to animals to humans, was composed of these primordial particles, waiting for the right conditions to sprout. His idea was not framed in modern biology, of course, but the intuition feels hauntingly familiar. Even then, people looked at the sky and wondered if life itself might be a traveller. The word we use now, panspermia, comes from Greek roots, pan meaning all, and sperma meaning seed. All seeds, sprinkled across the universe. The simplicity of it makes you pause. Life is not a miracle confined to a single planet. Life is dusted like pollen on the wind, invisible, patient, waiting to bloom wherever it lands. Mainstream science today treats panspermia with caution. The conventional explanation for life on Earth is abiogenesis. Chemistry gave rise to biology here, through complex interactions of molecules in warm oceans or deep hydrothermal vents. That story is still the leading one, backed by experiments that show amino acids and other building blocks can form under simulated early Earth conditions. Yet, panspermia hovers at the edge of credibility, like a shadow that refuses to vanish. Because as scientists study the resilience of microbes, the shadow grows longer. There are tiny creatures known as tardigrades, water bears, plump little eight-legged specks that can survive the vacuum of space, the radiation of orbit, and temperatures near absolute zero. They curl up into dehydrated husks called tun-states, and in that state they are almost indestructible. When you read about tardigrades clinging to spacecraft panels, surviving orbital exposure experiments, you can't help but think, if they can ride a satellite, could they also ride a comet? Scientists still argue whether even hardy microbes could survive the full journey thousands or millions of years. Adrift, bombarded by cosmic rays. Some calculations say yes, if shielded by thick rock or ice. Others point out that DNA is fragile, that radiation damage would accumulate. But the debate itself is tantalizing, because it means we cannot dismiss the possibility outright. And so your mind loops back to the ancients. When Anaxagoras imagined cosmic seeds, he lacked microscopes, lacked petri dishes, lacked the double helix. Yet in a sense, he was dreaming of panspermia centuries before the word existed. His seeds were metaphors. But what if metaphors sometimes turn out to be blueprints? Your thoughts drift forward in time, leaving ancient Greece behind and settling into the 19th century. A Swedish chemist named Svante Arrhenius took Anaxagoras' seeds and gave them a scientific twist. In 1903, he proposed that microscopic spores could be propelled through space by the pressure of starlight itself. Imagine it, sunlight not only warming and illuminating, but also pushing like a breeze that could blow entire motes of life from one world to another. The picture is oddly delicate. Spores drifting like dandelion fluff, nudged onward by rays that have travelled billions of kilometres. The odds of any one spore landing somewhere suitable are vanishingly small, of course, but space, like time, is patient. If you scatter enough seeds across enough centuries, perhaps one finds soil. Perhaps one takes root. In today's language, we sometimes call this radiopanspermia, the scattering of life by radiation pressure. Most mainstream biologists roll their eyes at it. Spores are fragile. The distances are staggering. Still, the idea lingers because light really does exert pressure. We build solar sails for spacecraft, harnessing that same principle to travel. If our machines can ride starlight, could microbes too, at least for a while? You picture Three-Eye Atlas in this light, not as a deliberate ship, but as an accidental carrier. Perhaps somewhere in its icy depths lie frozen organisms from a star system that no longer exists. They may not survive the trip. They may never stir again. Yet, the possibility clings like frost. Even a slim chance of survival is enough to make you wonder how many worlds have been brushed by invisible couriers. The quirky tidbit that always sparks a smile is that even Earth itself has probably been seeding the cosmos without meaning to. Every asteroid impact that struck our planet over billions of years would have blasted debris into space, chunks of rock carrying embedded microbes. Some of that debris might have wandered for eons, perhaps even slipping into the gravity wells of alien suns. Without knowing it, Earth may already be a gardener, scattering bits of itself into the dark. And so, panspermia ceases to be only a question of origin, it becomes a question of exchange. If worlds fling life outward like sparks, and if even a fraction of those sparks endure, then perhaps the galaxy is less like an empty desert and more like a meadow, cross-pollinated invisibly across time. Scientists still argue whether such exchanges could truly work. Some insist the odds are microscopic, some say they are inevitable given enough time, but late at night, those odds don't feel cold and mathematical. They feel like an invitation. If life can travel, then no world is truly isolated. Every planet becomes part of a larger, hidden conversation. As your imagination lingers on this possibility, you start to see panspermia less as a fringe theory and more as a poetic bridge. It ties Earth to the stars, our oceans to distant constellations. The line between science and mythology blurs again, just as it did for Anaxagoras 2,000 years ago. The ancients spoke of seeds, the moderns speak of microbes, but the essence is the same. Life is not rooted only in soil, it is carried on the wind of the cosmos. Consider the meteorites that fall to Earth. Some of them, like the famous Murchison meteorite, arrived carrying amino acids, the raw ingredients of proteins, embedded in rock that predates our planet. A sober fact for the textbooks: organic chemistry is not rare. It unfolds naturally in the cold of interstellar clouds, in the warmth of comets, in the pressure of planetary crusts. Life's building blocks are scattered everywhere, like flour dusting a kitchen counter after baking. And then there is the more curious angle. In 2015, researchers revived bacteria that had lain dormant in Siberian permafrost for over 30,000 years. They stirred back to life with nothing more than warmth and nutrients. If microbes can wait that long in frozen Earth, why not longer, deep in a comet's heart? Some argue that cosmic rays would eventually shred their DNA beyond repair, but others counter that shielding under meters of rock and ice could preserve them. Scientists still argue whether that preservation window is measured in thousands, millions, or even hundreds of millions of years. The thought slides quietly into place. If even one seed survives, the chain of life can continue. That makes 3i Atlas not only a traveller, but potentially a gardener. Not intentionally, perhaps not with purpose or design, but as part of the great unthinking engine of nature, flinging seeds across gulfs of night. And yet, you feel a hush at the edge of this idea, because there is always another possibility, the one harder to admit. What if panspermia is not accidental? What if somewhere long ago, a civilization looked at its dying world and decided to scatter life before the last fires burned out? Instead of messages and radio waves, they sent messages in cells. Instead of monuments in stone, they built monuments of DNA, not to be read immediately, but to bloom one day in alien soil, when someone or something was ready. The night grows quieter as you hold this thought. You can almost picture those long-vanished hands releasing their seed ships into the void, trusting not in certainty but in chance. The gesture is almost human, almost tender, to send life onward, knowing you will never see its harvest. And as you lie there, you wonder, could 3i Atlas be one such vessel? Is it carrying the faintest traces of a world we will never know, a world that still finds a way to echo here, in your ears, in this moment? The questions don't need answers tonight. They are enough, in their own right, to rock you gently, like waves against the shore of thought. You find yourself staring into the mental image of 3i Atlas again, this time not as a silent wanderer, but as something stranger. The idea arrives gently, as most midnight ideas do. What if it is not a rock at all? What if beneath its jagged surface lies intention? It is easy to laugh at such thoughts in daylight, when the mind is sharp and skeptical. Rocks are rocks, after all. Telescopes reveal rough surfaces, not gleaming hulls. Observatories report trajectories and chemical spectra, not secret cargo bays. But at night, when the world slows down and your imagination has room to breathe, the line between natural and artificial begins to blur. You picture it as a seed ship, a vessel camouflaged as an ordinary fragment of ice and stone. Its disguise is perfect. To most eyes, it is indistinguishable from the billions of comets and asteroids already drifting through the galaxy. But the disguise is also the genius of it. What better way to send life across interstellar distances than to hide it in plain sight, tucked inside something the cosmos already makes by the trillions? The mainstream fact remains simple. Comets really are rich in organic molecules. The Rosetta spacecraft, when it studied Comet 67P, found not just water, ice and dust, but amino acids and phosphorus ingredients of DNA itself. And so, imagining a comet-like vessel carrying life is not a leap from fantasy to fiction. It is a step along a bridge already built by chemistry. The quirky tidbit that makes the thought more vivid is that we humans have already begun building our own artificial comets. Small satellites have been designed with gene banks, holding samples of seeds, microbes, even animal DNA, stored for safekeeping in orbit or on the moon. We call them archives, or vaults. But from a distance, a tiny capsule glinting in sunlight might not look all that different from a pebble drifting in space. Perhaps 3i Atlas is simply a larger, older version of the same concept scaled up beyond our imagination, launched not by us but by someone else. Scientists still argue whether such ideas deserve attention at all. For every paper that speculates about artificial origin, there are 10 that dismiss it as science fiction, and perhaps they are right. But you notice that dismissal and proof are not the same thing. Until an object is cracked open and studied, its secret, if it has one, remains intact. So you let yourself drift with the fantasy. A vessel carved to look like stone, hollow inside, its chambers layered with frozen spores. No crew, no captain, no destination in mind. Just a quiet courier, set adrift with the patience of stars, carrying a cargo too small for telescopes to see. Close your eyes for a moment and imagine walking inside. The outer crust is thick and jagged, a wall of ancient ice and stone, but as you step through a fissure, you find a cavern, dark and glistening, lined with crystals that catch the faintest glimmers of starlight seeping through cracks. The air is absent. Of course, this is the silence of vacuum, but in your dreamlike vision, you feel the chambers as if they hold their breath, waiting. What would they hold? Perhaps racks of tiny pods, each one no larger than a grain of rice, each carrying genetic blueprints. Perhaps a frozen slurry of microbes, layered in protective shells, stacked like a library of life. Or perhaps something stranger, not life itself, but the instructions for life, encoded in patterns of molecules, waiting for chemistry to do the rest once they reach a new world. The mainstream fact that strengthens this thought is that DNA is astonishingly compact. All the information needed to build a human body, billions of base pairs, fits inside a nucleus invisible to the naked eye. An entire biosphere's worth of code could be stored in a capsule smaller than your fingertip. If evolution has taught us one thing, it is that life knows how to travel light. And yet, the quirky fringe glimmers too. There are experiments in synthetic biology where scientists encode messages, even entire images, into DNA strands. A group once embedded the lyrics of a song into bacterial DNA. Another encoded a short film into the genome of living cells. These are not mere stunts, they are proof that DNA is more than blueprint. It is also storage, archive, memory. Suddenly, imagining a seed ship carrying not just organisms but stories does not feel impossible. Scientists still argue whether such encoding could last across cosmic timescales. Could DNA survive 1 million years? 1 billion? Some say it would crumble, no matter the protection. Others counter that with the right shielding deep ice, rock, or engineered molecules it might endure. The truth hides somewhere in between, in that wide gulf where certainty fades into speculation. Your mind drifts back to Three-Eye Atlas, gliding silently in its camouflage. From the outside, astronomers see only the barest details: faint light curves, a rough trajectory, the suggestion of volatile ices sublimating into space. But from the inside, in your imagination, it becomes something more, a reliquary of possibility, carrying not just matter, but meaning. And then comes the question that presses softly at your thoughts. If this is a vessel, who launched it? Did they build thousands, flinging them outward like pollen? Did they launch only one, trusting the universe to guide it where it belonged? Or was it an accident, a failed machine still drifting with a mission long forgotten? The thought hovers like a half-remembered dream, a civilization, ancient and far away, facing its twilight. Perhaps their sun was swelling, or their oceans drying, or their skies filling with storms. Faced with the inevitable, they might have chosen not to save themselves with their UTVS, but to save the idea of themselves, not ships for their bodies, but ships for their essence. Three-Eye Atlas, in this vision, becomes not a rock, but a time capsule, a way of saying, we were here, not through monuments or messages carved in stone, but through the only medium with a chance to persist across eons: biology. In that sense, it is less like a spacecraft and more like a bottle tossed into an ocean, carrying seeds instead of words, trusting the tide to do the rest. The mainstream evidence that nudges your mind further is the discovery of extremophiles on Earth, microbes living in conditions once thought impossible. Bacteria thriving in radioactive waste, archaea swimming in boiling acid pools, fungi dining on pure rock. If life can adapt so flexibly here, why couldn't it be adapted, or even engineered, to endure a journey through the stars? And there is a quirkier side that makes you smile. Some researchers have suggested humans themselves might one day send seed ships. Not grand starships with crews, but small capsules packed with frozen embryos, stem cells, or synthetic DNA, dispatched toward nearby stars. It is, in some ways, cheaper and easier than sending bulky bodies. If we are already imagining such missions for ourselves, how strange is it to wonder if others imagined it first? Scientists still argue whether such projects should ever be attempted. Some warn of contamination, of playing gardener where we do not belong. Others argue the opposite, that life deserves to spread, to test its resilience, to fill the void with green and breath and song. The debate has no neat resolution, only a horizon of open questions stretching like the Milky Way itself. And so you lie back with your thoughts, holding both possibilities at once. On one hand, Three-Eye Atlas is only a fragment of ice and dust, a natural wanderer, one of countless billions. On the other, it is a disguised vessel, a patient courier, an ark of life hidden within stone. Both truths can coexist in the same night sky, just as wonder and skepticism coexist in the same heart. As you drift further into this idea, the object itself seems to drift closer, not in miles but in intimacy. No longer just a distant speck on astronomers' charts, it becomes part of your imagination's inner orbit. A rock or a ship, a stranger or a messenger, a question carved in ice, waiting for an answer that may never come. And with that lingering uncertainty, your mind begins to lean gently toward the next thought. If it truly carries cargo, what could that cargo be? You drift now into the interior of imagination, as if the surface of Three-Eye Atlas has cracked open, revealing what lies within. The crust of stone and ice gives way to a hollow, and inside there is cargo not in the way a human ship carries crates and fuel, but in the quieter, stranger sense of biology preserved for a journey without end. Picture frozen microbes, curled tight into states of suspended animation. On Earth, such survival tricks are common. Bacteria lock themselves in hardy spores, able to outlast droughts, radiation, even the vacuum of space. Some spores revived after lying dormant for tens of millions of years, pulled from ancient salt crystals, springing back to life when given water and warmth. If Earth's microbes can do this, might not others ride inside a vessel like Three-Eye Atlas, awaiting a new dawn? The mainstream fact is simple but awe-inspiring. Life is astonishingly resilient. Microbes have survived on the exterior of the International Space Station for years, enduring cycles of freezing and frying temperatures, bombarded by cosmic rays. Some return to Earth still viable. To scientists, it proves that biology can endure far harsher environments than once believed. To you, it whispers that the line between impossibility and possibility is thinner than you thought. And then comes the quirky tidbit. In 2019, researchers sent small organisms, including tardigrades, aboard an Israeli lunar lander that crash-landed on the moon. The lander shattered, scattering its tiny passengers. Some argue the tardigrades may still be up there, intact, embedded in lunar soil, waiting. Whether true or not, the story is irresistible. It paints the moon as an accidental petri dish seeded by human hands. Suddenly, the idea of life riding along on cosmic journeys doesn't feel like fantasy. It feels like history already in progress. Scientists still argue whether microbes could actually establish life if they landed on a new world. Some say yes. With the right warmth and chemistry, they could multiply, adapt, evolve. Others caution that survival is not the same as thriving, that alien environments would crush or starve them. Yet the debate itself makes the possibility shimmer, like moonlight across a dark lake. Now imagine 3I Atlas striking a barren planet. The impact would be violent, yes, but the interior might survive, shielded from the blast. A handful of spores tumble free, settle into cracks warmed by geothermal heat, and begin their patient work. Centuries later, perhaps rivers form, skies thicken, and life quietly takes hold. The courier's mission is fulfilled, even if no one remembers who launched it. In your mind's eye, you drift closer to that imagined cargo hold. The silence is total, yet it feels alive in its waiting. Perhaps what rests there is not only microbes, but frozen strands of DNA, like scrolls in a cosmic library. DNA is not indestructible, but when locked in ice or salt crystals, it can linger far longer than we once believed. Ancient horse DNA has been recovered from permafrost after hundreds of thousands of years. Plant seeds dug up from Arctic tundra have germinated again after millennia. Time stretches differently for the patient. The mainstream fact that buoys this thought is the discovery of complex organic molecules on comets. Missions like Rosetta revealed that these icy wanderers contain sugars, amino acids, and the building blocks of nucleic acids. In other words, the same chemistry that underpins our cells is not unique to Earth, it is scattered widely through the cosmos. If such ingredients are already stashed inside natural comets, how much more compelling the idea becomes when imagining them deliberately packed, chosen, curated. And then comes the playful fringe. Some have suggested that what we think of as random organics might actually be signals in disguise, patterns hinting at intention. No evidence demands this, but the speculation persists in the margins of astrobiology. What if, instead of plain molecules, a ship like 3I Atlas carried coded polymers, messages hidden in chemical sequences, not words or pictures, but recipes for life itself? Scientists still argue whether life needs to arrive whole, as spores, or whether ingredients alone would suffice. Some models suggest that simply dropping amino acids onto a young, watery world could spark the cascade of chemistry that leads to biology. Others counter that without highly complex structures, enzymes, membranes, full genomes, the leap would be too vast. But again, the truth is uncertain, and uncertainty is fertile ground for wonder. Picture 3I Atlas grazing past a barren exoplanet, its crust fractured by heat, shedding shards like dandelion seeds. Each shard melts into the atmosphere, raining fragments of DNA, proteins, or simple organics onto the surface below. Most perish instantly. But one fragment finds a warm pond, a crack in volcanic rock, a chemical cradle, and from that humble start, an entire world begins to stir. The thought is almost dizzying. The future of a planet, cradled in the dust of a passing stone. Let your mind linger on that vision. A barren landscape, perhaps cold and airless, suddenly brushed by something older than its mountains. The cargo of life is not grand or dramatic. It is subtle, quiet, hidden in microscopic shells. Yet, if even a fraction survives, the silence of a world can be broken. The mainstream record reminds you that meteorites from Mars have landed on Earth, carrying traces of ancient chemistry. Some even hold structures that resemble microbial fossils debated endlessly, never confirmed, but never entirely dismissed. If rocks can leap between planets within one solar system, why not between stars? If debris can carry chemistry from Mars to Earth, why not from a place we've never named to a world we do not yet know? The quirky tidbit that lingers in your thoughts is that scientists once revived a date palm seed discovered in the ruins of Masada, Israel. The seed had waited for nearly 2,000 years, forgotten in a jar, until modern gardeners coaxed it back to life. Today, that palm grows tall again, bridging centuries with nothing but patience. It makes you wonder how long seeds, whether plant or microbial, can wait when locked away in darkness. Perhaps eternity is shorter than we think, and patience is longer. Scientists still argue whether such cargo could ever truly transform a planet. Would microbes adapt, or would alien soil poison them? Would DNA unravel before it could replicate, or would chemistry pick up where the old world left off? The debate has no single answer, only probabilities shifting like shadows. But in the stillness of night, probability feels less important than possibility. So you picture 3i Atlas as more than a stone. You see it as a courier of hope, a drifting library of frozen seeds. It may never break open, never scatter its contents. It may drift forever, locked and silent. But the possibility that it could, that it carries the potential for oceans and forests and skies on some lonely planet, that is enough to keep the wonder alive. And as you settle deeper into thought, the question naturally grows. If this vessel carries seeds, whose design do they follow? Are they the blind children of chemistry, or the deliberate blueprint of a civilization that chose to plant life where it could never walk itself? That quiet uncertainty guides you toward the next turn in your journey. The thought sharpens as you imagine the cargo of life not merely as random spores or frozen microbes, but as something more deliberate. What if the contents of 3i Atlas are not seeds in the sense of nature, but blueprints designed, chosen, and carefully stored? It is one thing to scatter spores across the galaxy and hope for the best. It is another to send instructions, a recipe that can be followed when the right conditions arise. You picture a civilization, long vanished, carefully encoding strands of DNA, or even stranger molecules, arranging them like letters in a library that could outlast suns. To stumble upon such a library would be to receive a gift, not just life, but the means to create it anew. The mainstream fact that whispers here is that humans already treat DNA as an information system. In laboratories today, researchers have encoded Shakespeare's sonnets, digital photographs, even computer programs, into strands of synthetic DNA. The density of storage is beyond imagination. All the world's data could, in theory, fit into a shoebox of DNA molecules. If we, a young species barely learning to leave our planet, can already play with this idea, then what might an older, more advanced species have achieved? The quirky tidbit that makes the thought shimmer is that some biologists have speculated whether Earth's DNA itself could contain hidden messages. It is fringe, yes, but there are papers in serious journals asking if mathematical patterns in the genetic code might be signatures, like graffiti left by an architect. Nothing conclusive has ever been found, but the very fact that scientists dare to ask tells you how fertile the question island. Scientists still argue whether life's complexity is better explained by pure chance or by some guiding hand, natural or otherwise. Evolution, as we understand it, is a blind sculptor, shaping form through trial and error. But what if, in at least one place, the sculptor was helped along by instructions carried on a vessel like 3i Atlas? What if what we see as biology is, at its root, also technology? The idea unsettles and soothes in equal measure. It unsettles because it challenges the story we tell ourselves, that life here began as a local accident. It soothes because it suggests kinship, a connection, a thread binding us to ancestors we have never met. You close your eyes and picture those ancestors, not as faces but as hands. Hands arranging molecules the way we arrange books. Hands tucking them into the icy heart of a vessel. Hands releasing it into the dark with a hope too large for words. Your imagination drifts deeper into this possibility, that 3i Atlas carries not life itself, but the designs of life. Imagine a chamber inside the vessel, where information is stored in ways we can barely conceive, spirals within spirals, molecules folded into fractal codes, patterns that unlock only under certain conditions, it would be less like a seed vault and more like a cosmic manual, waiting for someone, somewhere, to open it. The mainstream fact that adds weight here is that genomes already act as manuals on Earth. A single fertilized egg contains all the information needed to build a body: eyes, skin, muscles, memories waiting to be etched. We call this process natural, but the architecture is exquisite. Each cell is a library, and each strand of DNA is both text and machinery, both archive and active script. If nature can write such manuals by chance, how might intelligence refine them by design? The fringe idea that curls at the edge of thought is that civilizations could send engineered genetic toolkits across space. Not fully formed organisms, but packages containing proteins, enzymes, and raw instructions. A planetary chemistry lab could do the rest, assembling life like a recipe once the ingredients are poured together. This concept, sometimes called genetic seeding, has appeared in speculative astrobiology circles, dismissed by some, but pondered seriously by others, who note its elegance. Scientists still argue whether this level of foresight is plausible. Could DNA or any molecular code truly survive cosmic radiation for millions of years? Could instructions be written in polymers more stable than anything we know? Some say it is fantasy. Others point out that our own species is already seeking to create molecules more robust than DNA, synthetic codes that could endure the rigors of space. If we are just beginning to think this way, why assume we are the first? You picture again the hands of those unknown architects, working with patience that defies imagination. They do not sculpt monuments or build fleets of warships. Instead, they design blueprints of being, tiny enough to hide in ice, vast enough to unfurl into forests, oceans, and mines. Their ship drifts not with weapons but with words unspoken, with futures encoded, with hope disguised as dust. And as you let that thought sink in, you begin to feel a curious intimacy. If such blueprints exist inside 3i Atlas, then perhaps you, here and now, are already one of its outcomes. Perhaps we are not waiting to receive such a message, we already are the message, carried forward alive and listening. Let the thought unfold slowly, a vessel drifting through the dark, carrying not passengers but possibility. Its hull is rough and silent, but within it lies an archive far greater than libraries of stone or metal. An archive not of knowledge alone but of being itself. The mainstream fact that strengthens this vision is the resilience of genetic material under the right conditions. Frozen mammoth DNA, preserved in Siberian ice for tens of thousands of years, has been reconstructed and sequenced in modern labs. Some fragments were intact enough to spark discussions of cloning. If fragile DNA can endure that long on Earth, perhaps there are molecular systems designed to last far longer, meant specifically to survive the void. The quirky detail that makes you smile is that researchers once discovered a bacterium, Deinococcus radiodurans, nicknamed Conan the bacterium. It can survive doses of radiation thousands of times higher than what would kill a human. It repairs its shattered DNA like a mechanic patching a broken machine. When you hear of a cell that can laugh off what would incinerate us, you begin to see biology itself as a technology, one that might have been refined, repurposed, even exported by minds older than ours. Scientists still argue whether we should even be looking for such evidence. Some caution that to frame life as engineered risks, diminishing the wonder of natural evolution. Others argue that evolution and engineering are not opposites but continuations, that intelligence is itself a natural outcome, and with it comes the urge to create. If that is true, then perhaps somewhere out there, long before us, someone chose to leave their mark, not in monuments of stone, but in strands of code. As you lie back with that thought, 3i Atlas seems to shimmer in your imagination. No longer just a rock, it becomes a reliquary of intention, a drifting message in molecular script. Perhaps it carries blueprints for forests never seen, oceans never sailed, creatures never born. Perhaps it carries only silence, its archive long decayed. Both possibilities matter, because both remind you that the cosmos is not just a backdrop of stars, it is a canvas of potential. And so the question lingers softly. If life can be written, and if those blueprints were ever scattered into the dark, then what are we to make of our own existence? Are we the architects, the gardeners, or simply one more harvest from someone else's design? The answer does not come. It does not need to. The beauty lies in the wondering itself, the slow unfolding of possibility as you drift deeper into the story of this quiet visitor. You let the idea settle like dew on quiet grass. If 3i Atlas carries blueprints of life, then what does that say about us? Perhaps the most daring possibility is also the most intimate, that we ourselves might be the harvest of a seed planted long ago. It sounds bold, almost too bold, yet the thought carries a curious tenderness. Imagine that Earth in its infancy was brushed by a vessel like this. A shard broke open, scattering microscopic passengers into young oceans. They drifted in the salt and warmth, multiplied, adapted, and slowly, over billions of years, gave rise to everything: trees, birds, whales, humans. If that story is true, then looking at 3i Atlas is like looking into a mirror tilted back through time. The mainstream fact that makes this dream less far-fetched is that all known life on Earth shares a common ancestor. Every organism, from the tiniest bacteria to the tallest redwood, carries the same fundamental code, the same 4-letter alphabet of DNA. This unity suggests that life began once here, then branched and diversified. But if that once was seeded from beyond, then our family tree has roots that stretch not just into the soil but into the stars. And then comes the quirky glimmer. In 2013, scientists found microbes high in Earth's stratosphere, 30 kilometers above the ground, where no weather balloon expected to catch them. Some speculated they might have drifted from space, though others argued they were simply lofted upward by storms. The evidence is debated, inconclusive, but tantalizing. If microbes can survive there, riding winds at the edge of space, perhaps they can also arrive from farther afield. Scientists still argue whether life's genetic code is universal by accident or design. Some say it is the inevitable outcome of chemistry, that any world would stumble into similar solutions. Others wonder whether the universality hints at a shared origin, a seed scattered widely and sprouting wherever conditions allowed. To hold that thought is to imagine a galaxy where countless planets host cousins, not metaphorical cousins, but true relatives, sharing echoes of the same code that runs in your veins. You pause on that image. Relatives you will never meet, scattered across unimaginable distances, carrying in their cells a faint signature that ties them to you. The idea makes the night sky feel less lonely. Let your imagination drift outward, across the gulf of stars, where countless worlds circle their suns in silence. If Earth was seeded once, perhaps those other worlds were too. Each planet would carry its own version of the story, the same melody played in different keys. Some might have failed, their seeds falling on barren rock, never stirring. Others could be thriving. Oceans alive with creatures whose cells hum with the same rhythm as ours. You think about how the genetic code is both rigid and playful. The letters are the same everywhere in life, yet their combinations give rise to endless variety. In another system, far from our own, those combinations might have unfolded into forms beyond imagination, creatures gliding through methane clouds, forests of crystal branching under alien skies, beings whose senses are tuned to wavelengths we cannot even see. And yet, buried deep in their chemistry, there might be a flicker of recognition, a thread of code that would feel familiar if ever compared. On Earth, scientists already search for those threads. They sift through ancient rocks for isotopic signatures, chase the faint traces of amino acids in meteorites, and probe Mars for any clue that might confirm a second genesis. What they find, more often than not, are tantalizing maybes, patterns that resemble life, but stop short of proof. And in that hesitation lies the allure, because if even one of those maybes tipped into certainty, the implication would be immense that our lineage stretches beyond this planet into an ancestral chain we cannot yet see. The night itself feels different when you hold that thought. The stars are not just distant lights, but possible homes of kin. You may never share words with them, never trade stories, never know their myths. but knowing they might exist changes the way you feel the silence. It becomes less empty, less cold, more like the hush of a family gathering where some faces remain hidden just beyond the firelight. And if 3i Atlas is truly such a courier, then watching it pass is like glimpsing an older sibling you never knew you had, vanishing into the dark before you could wave. You rest with the idea a little longer, letting it take root in the quiet. If our story began with a seed from elsewhere, then we are not only earthlings. We are citizens of a larger, older lineage that stretches through the stars. Every heartbeat could be echoing a rhythm set in motion billions of years ago, by hands or by forces we will never meet. Think of it this way: the veins of a leaf, the spiral of a seashell, the curve of your own fingerprints. All these patterns might have cousins across unimaginable distances. They would not look the same, yet in their architecture you might sense a resemblance, the way distant relatives share the shape of a smile or the cadence of laughter. Even here on Earth, we sometimes feel awe at the resilience of life in the strangest places, creatures thriving in volcanic vents, in frozen deserts, in caves sealed off from sunlight for millions of years. If such tenacity can be found here, perhaps it was inherited from a deeper source, a resilience that belongs not to Earth alone, but to the legacy of travelling seeds. And if that is true, then perhaps gazing into the night sky is not about seeking strangers, but about longing for family. The galaxies overhead might be nurseries, each raising children from the same scattered inheritance. You and those unseen cousins would never exchange words, but in your shared chemistry, you would already understand one another. So when 3i Atlas drifts past, silent and unblinking, it may be more than an object of curiosity. It may be a reminder. We are not an isolated accident, but part of a tapestry too vast to trace. To imagine such kinship is to feel less alone in the darkness, to sense that the universe itself is threaded with relation. The thought lingers as softly as a lullaby: you, me, the forests, the oceans, the stars, all cousins in a family too immense to gather in one place, yet still connected by roots deeper than time. The picture of 3i Atlas grows colder and more vivid. You start to see it not only as a visitor, but as something older and more solemn, a frozen ark drifting endlessly, like Noah's vessel set adrift, not on seas of water, but on the tide of the cosmos itself. Imagine its surface battered by micrometeorites, its crust scarred by countless collisions, yet still holding tight to what lies within. The ark does not need sails or rudders. Its navigation is gravity, its engine is time. It travels not with intention but with inevitability, and that inevitability makes it strangely powerful. The mainstream fact is that comets and icy bodies truly can preserve materials for astonishing spans. Deep inside, shielded from cosmic radiation by thick layers of rock and ice, molecules can remain intact for millions of years. Samples from Antarctic ice and permafrost show us microbes that have waited patiently in suspended animation, reawakening when thawed. A frozen ark, then, is not only metaphor, it is also a possibility rooted in observation. The quirky tidbit that makes the idea sparkle is how humans themselves have begun creating arks of their own. On the island of Svalbard in Norway sits the Global Seed Vault, a subterranean chamber packed with seeds from around the world, meant to survive catastrophes. In orbit, scientists dream of storing digital DNA archives on the Moon or Mars, preserving Earth's heritage beyond Earth itself. If we, in our brief history, already dream of freezing life for safekeeping, why not others, far older, far more desperate? Scientists still argue whether such vaults could ever truly last in space. Some warn that cosmic rays eventually shred even the best protected DNA. Others argue that with enough shielding and enough redundancy, survival is likely. The truth drifts between these poles, an unresolved chord in the symphony of possibility. And so, the vision of 3i Atlas as a frozen ark begins to feel natural. A ship without crew, a library without shelves, a vessel whose mission is only to endure. It doesn't promise survival to every seed within it, only the chance, the fragile possibility that somewhere, someday, one of those seeds might find soil. Picture yourself standing on the imagined deck of this ark. There are no sails above you, only the black expanse of space. No sound of waves, only silence thick enough to feel like a weight. The hull beneath your feet is not wood but a crust of ancient ice, chipped and fractured but still stubbornly whole. It has been travelling for ages without a single hand to steer it. Yet somehow, here it is, brushing past the light of our Sunday. The idea resonates with the long tradition of arks in human culture. The ark is always about preservation, saving fragments of life when disaster looms. In myths, arks protect animals from floods, scriptures from fire, people from annihilation. The frozen arc of space is no different, except its flood is time itself, its storm is radiation, and its salvation lies in patience. The mainstream science that makes this vision credible is the discovery of organic molecules in comets. The Rosetta spacecraft study of Comet 67P revealed not just simple building blocks, but more complex chemistry: glycine, phosphorus, sugars. These are not life, but they are the alphabet from which life can be written. Protected deep inside, such molecules can endure eons. An ark, then, could carry not just seeds but recipes, chemical blueprints wrapped in ice. The quirky side of the thought is that even Earth has acted as an ark, flinging pieces of itself into space during asteroid impacts. Some of those fragments may still wander the galaxy with microbes tucked inside. In this light, Earth has been a reluctant gardener, scattering spores of its own without knowing. Our planet, too, has contributed to the silent migration of life. Debates still linger over the limits of such endurance. Can spores really survive millions of years in deep freeze? Can DNA truly withstand the constant needle pricks of cosmic rays? Some biologists doubt it. Others find it plausible under the right shielding. The uncertainty itself feels like part of the ark's mystery. Like a locked chest found in an attic, you cannot know what it holds until you open it. And so, when you let your thoughts dwell on Three-Eye Atlas, you no longer see only a rogue rock. You see a vessel carrying a faint cargo, drifting not to arrive anywhere in particular but simply to outlast silence. That endurance alone feels like a kind of message, as though the universe is saying, life matters enough to preserve, even when no one is there to watch. Let the vision linger. The ark drifts in darkness, indifferent to whether it will ever reach a shore. Perhaps it will wander until the end of the galaxy's time, never breaking open, never scattering its hidden treasures. Yet the power of the idea lies not in certainty but in possibility. Even if only 1 in a million such arks ever awakens, that would be enough to paint the universe with life. Earth itself offers reminders of how little is needed. A single seed, long forgotten in ancient soil, can sprout when given water and sunday. A single microbe, thawed from ice, can multiply into colonies by the billions. The scale of the harvest never diminishes the miracle of the first awakening. In the same way, the frozen ark does not need to succeed often. It only needs to succeed once in a while, and eternity provides endless chances. Human imagination has long leaned toward such metaphors. The ark, the vault, the capsule buried in time, all are symbols of trust. You bury something precious, not because you know it will be found, but because you hope it might. Three-Eye Atlas embodies that same trust, whether shaped by chance or by will, that the universe is worth seeding, even if you never see what grows. There is still disagreement, of course. Some scientists see these visitors as nothing more than debris, leftovers of planetary formation. To them, talk of arks is romance, not reality. Others point to the resilience of biology and argue that such resilience naturally extends beyond borders we once thought impassable. Between skepticism and belief lies a quiet middle ground, the kind of space where imagination can rest without needing to prove itself. So, when you picture Three-Eye Atlas gliding silently across the sky, think of it not only as a rock, but as a possibility, a frozen ark that may never open, yet still carries the dream of continuity. A dream that life is not fragile, not fleeting, but durable enough to survive the long night between stars. And as that dream settles, a new question glimmers faintly on the horizon. If this ark is real, why now? Why has it appeared in our skies at this exact moment in history, brushing so close to our awareness when for so long it drifted unseen? The ark drifts further into thought, and with it comes an unsettling question. Why now? Out of billions of years, countless eons where no human eyes looked upward, 3i Atlas appears during our brief moment of awareness. The timing feels almost too sharp, as though the cosmos waited for us to be ready. Astronomers, of course, lean on chance. They would say our instruments are better now, our surveys broader, our technology more watchful. Of course, we are spotting more visitors, we're finally paying attention. And yet, lying here with the night pressing softly against the window, you can't help wondering if there's more to it. Imagine the story told another way. A bottle tossed into the ocean doesn't care when it washes ashore, but to the castaway who finds it, the timing feels fated. 3i Atlas may be nothing more than that debris drifting until we happen to glance up. Still, the discovery resonates because it collides with our own moment in history, an age when we are just beginning to think about our place beyond Earth, just beginning to launch our own probes into the dark. In folklore, visitors never arrive without purpose. A wandering stranger reaches the village gate on the very night a prophecy is spoken. A gift is delivered on the eve of need. Even in our science fiction, timing matters. A signal intercepted too early would be ignored, too late, and it would be useless. Only at the fragile edge of awareness does the message truly land. And so, as you follow 3i Atlas across the mind sky, you wonder, is this timing purely coincidence, or does the universe have a rhythm we do not yet hear? Think about the narrow span of human history. For 4.5 billion years, Earth has circled the sun unseen, life crawling from oceans to forests to cities, all without knowing what passed silently overhead. Only in the last few centuries have we had telescopes. Only in the last few decades the sensitive surveys that sweep the heavens every night. And it is exactly in this thin sliver of time that 3i Atlas comes into view. From a scientist's desk, the explanation is straightforward. Millions of such objects cross interstellar space, and most pass unseen. With enough watching, sooner or later one was bound to appear during our lifetime. From a dreamer's bed, though, the thought lands differently. The timing feels like a glance held too long to be accidental. Stories of timing shape our own lives. The way you meet someone at just the right moment, a coincidence that bends your entire path. The way a letter arrives on the very day you needed it most. Perhaps the cosmos has its own way of weaving such moments. Perhaps the ark's arrival is not chosen, but it feels chosen, the way fate always does when it brushes close. There is even a curious detail. The pace of discovery has grown so quickly that Oumuamua, Borisov, and now 3i Atlas were all found within a handful of years. After billions of years of blindness, 3 visitors reveal themselves almost back to back. Statistically, that can be explained. Emotionally, it feels like the universe knocking 3 times in quick succession, asking if we're awake. Skeptics argue that such feelings are nothing more than pattern seeking. Believers lean in, asking if perhaps the pattern is real. Between them lies the open space where wonder lives best, the possibility that coincidence can still feel like conversation. The thought lingers as you imagine the ark's patient journey. For ages it drifted unseen. Through voids so wide, entire civilizations could rise and fall without ever noticing its passing. Then, just as our own species learns to listen and watch, it glides into our sightline. The overlap feels almost theatrical, as though a curtain has lifted for our benefit alone. If you frame it as chance, it is still beautiful, a reminder that the universe is wide enough for improbability to become reality. If you frame it as intent, the beauty deepens into mystery. Who sent it, and why now? Perhaps no one. Perhaps it is the cosmos itself that sends reminders at moments of readiness, nudging us toward greater questions. Human beings have always been attuned to timing. We celebrate arrivals, a newborn at dawn, a comet coinciding with an emperor's death, a rainbow after the rain. We cannot help but read meaning into synchronicity. 3i Atlas offers the same temptation. It brushes our awareness during an age when we are no longer content with Earth alone, when we send probes to other planets and whisper about starships to come. The timing feels like a mirror, reflecting our own awakening curiosity. Some scientists shrug. Coincidence explains everything. Others admit quietly that the coincidence is striking. And between those views lies the truth we feel most strongly tonight, that the arrival of such a visitor is not just data but story. It is an intersection of orbit and consciousness, of wandering ice and watching minds. So you let the question remain unresolved. Did 3i Atlas appear in our age by accident or by some rhythm we cannot yet hear? The uncertainty is its gift. It turns an ordinary night sky into a stage where even rocks can play roles, where timing itself feels like a message. And as you drift with that thought, another image stirs. If such arks truly scatter seeds, then some must land unseen, tucked away in shadows where life may one day awaken. Seeds in the dark, waiting for their own timing to arrive. Picture 3i Atlas not as it drifts past us, but as it might one day collide with a distant world. Not a lush paradise with blue skies and oceans, but a barren place, silent and cold, where stone outweighs atmosphere and light struggles to reach the ground. To us it looks lifeless, inhospitable, but to a seed ship, such a place is not the end. It is the beginning. Imagine the impact carving a crater, heat and shock tearing open its frozen heart. Out of the fractured body tumble tiny passengers' spores curled in on themselves, fragments of DNA, molecules built for patience. Most are obliterated instantly, vaporized in the violence, but a few, shielded in cracks, survive and scatter into the dust. On Earth we know that life does not require comfort to start, it only requires opportunity. Deep in the ocean, in the pitch-black chimneys of hydrothermal vents, entire ecosystems flourish without sunlight, fed by chemical reactions. Microbes live kilometers underground, sealed off from the surface, surviving on rock and water alone. These examples prove that shadows are not lifeless by default. They are simply waiting for the right spark. The quirky twist is that life often hides in places we overlook. In the frozen soils of Antarctica, microbes stir when given warmth, as if they had only paused their clocks. In caves filled with poisonous gases, bacteria thrive where no larger creature dares go. Even inside nuclear reactors, fungi have adapted to feast on radiation. If Earth can fill its shadows with such surprises, then another world, seeded by a passing ark, might do the same. Scientists still argue whether panspermia would ever work in practice. Some say that without a thick atmosphere or liquid water, the seeds would simply lie dormant forever. Others suggest that even dormancy is a form of success because time reshapes planets. Volcanoes erupt, ice melts, impacts deliver water. A seed can wait, held in darkness, until the world itself becomes ready to nurture it. So the vision grows, a barren landscape, seemingly dead, quietly hiding the ingredients of life beneath its surface. A waiting garden, invisible for now, but destined to bloom when conditions allow. Picture that lonely world centuries after the impact. The crater has cooled, winds have swept dust across the scar, and the ark itself is nothing but rubble half buried in rock. Yet somewhere in the cracks, water seeps in, maybe from melting ice, maybe from hidden underground reservoirs. A trickle becomes a pool, warmed by the planet's core, and within that damp shelter, the seeds stir. They do not awaken dramatically. No instant forests, no sudden creatures walking on legs. Instead, the process is microscopic, patient, almost invisible. Molecules click together into chains, chains fold into patterns, and patterns learn to copy themselves. A single spark of replication is enough. With each cycle, life takes a stronger hold, no matter how faint. On Earth, we see echoes of this beginning everywhere. Stromatolites, layered mounds built by microbial colonies, are among the oldest fossils, stretching back more than 3 billion years. They show that life clings fiercely to shallow pools and shorelines, expanding grain by grain. It does not need grandeur to succeed. It only needs persistence. There's a fascinating parallel in how seeds behave here at home. Some desert plants produce seeds so tough they can remain buried for decades, only sprouting after rare rains. To anyone watching, the ground seems dead until the desert suddenly explodes with colour. Imagine the same on a planetary scale. Eons of quiet, followed by a sudden flourishing, sparked by seeds delivered long before. Not all scientists are convinced. Critics argue that the odds are crushingly small. A seed might land, yes, But what are the chances it finds water? What are the chances conditions last long enough for evolution to take hold? And yet, probabilities are slippery in a universe this vast. If trillions of seed-bearing rocks wander the stars, then even impossible odds become inevitable somewhere. So when you imagine 3i Atlas, you can't help but picture it not only as a traveller but as a gardener that never sees its crops, sowing in silence, trusting the shadows to keep watch until the light finally arrives. Let the centuries unroll further. The seeds, once scattered in silence, begin to change their host. A thin haze of microbes clings to rocks near hot springs. Pools darken with the faint green shimmer of new chemistry, the quiet breath of photosynthesis. Slowly, the planet exhales a different atmosphere, each tiny exhalation adding to the whole until the world itself begins to shift. It is almost impossible to picture in human terms, because the timeline is so vast. What begins as shadows and trickles might take millions of years to become rivers and forests. Yet the principle is simple. Small lives accumulate into large changes. Just as moss spreads across stone, just as coral builds entire reefs, so too could microscopic passengers from an ark like 3i Atlas reshape a barren sphere into something vibrant. On Earth, evidence of such transformations is carved into the rocks. Ancient banded iron formations tell us that early microbes altered the chemistry of the oceans and skies, paving the way for more complex beings to rise. Without those first invisible workers, there would be no trees, no animals, no humans to look up at the stars. That history whispers that seeds, once awakened, have the power to remake worlds. Skeptics remind us that just as seeds can bloom, they can also fail. Countless planets may have received such gifts only to stay silent, their conditions never quite right. Perhaps most of the galaxy is filled with these quiet graves of possibility. Yet even if 99 out of 100 arks are lost to sterility, the one that succeeds changes everything. One flourishing is enough to tip the balance of a universe from lifeless to alive. And so, you imagine a far-off planet where no eye will ever watch, no intelligence will ever name its seas, yet still, forests rise from seeds that once drifted unseen. A miracle repeated, hidden in shadow, unnoticed but no less profound. 3i Atlas, in that vision, is not just a visitor passing through our skies. It is a whisper of what might already be happening elsewhere. Gardens blooming in silence, life taking root where no one thought it could, seeds unfolding their long patience in the shelter of the dark. As you imagine those hidden gardens taking root in distant shadows, another thought presses forward, quiet but insistent. What if life itself is the message? Not just a phenomenon that arises wherever conditions allow, but a deliberate form of communication, a way for the universe, or for civilizations within it, to speak across gulfs of silence. 3i Atlas begins to look different under that lens. Its icy body, tumbling through space, could be read as more than a traveller. It could be a courier, carrying not only the potential for biology but also the intention of connection. A letter, written not in words or symbols, but in the resilient script of DNA and proteins. If so, it is not only a vessel of survival, it is a message capsule, cast into the cosmic sea. Science has already hinted at this possibility in unexpected ways. In the double helix of DNA, we have discovered not just functional coding but also astonishing efficiency. A single gram of DNA can theoretically store hundreds of petabytes of information. Already, researchers have encoded poems, images, even entire films into strands of synthetic DNA, proving that life's alphabet is more than capable of carrying meaning beyond biology. If we can do this in our infancy as a technological species, what might older intelligences have achieved with the same medium? History provides its own curious parallels. Humans have always used durable materials to send messages into the future: carvings on stone, inscriptions on gold plates, the grooves of vinyl records, and now digital archives scattered across satellites. Perhaps biology is the most enduring medium of all, capable of traversing not just centuries but geological eras. Sending life may be the clearest way to say, we were here and we wanted to be known. Of course the debate lingers. Is life too chaotic to be considered a message? Many argue that it evolves unpredictably, that whatever was sent would soon lose its original form. Yet even a distorted message can still convey intent. A single spark of life on a foreign world would be enough to reveal that someone, somewhere, chose to share their existence. And so, as 3i Atlas slips through our system, you begin to sense it less as a rock and more as a whisper. A silent note carried across unimaginable distances, not waiting for reply but content simply to arrive. Think about the way humans already attempt to send our presence into the cosmos. We launch golden records etched with sounds of Earth, plaques engraved with diagrams of our location, and beams of radio waves pulsing toward nearby stars. Each of these efforts is fragile. In its own way, records can erode, signals can fade, interpretations can fail. But life, once it takes hold, speaks for itself. Imagine a distant planet where an ark like 3i Atlas crashes and seeds take root. Centuries pass, oceans fill with microbes, and eventually creatures crawl, walk and wonder. Those beings might never know where their spark originated, yet their very existence is a message, proof that they are kin to whoever sent the seed. Life doesn't need translation, it announces itself in every movement, every breath, every beating heart. Here on Earth, we've learned that DNA is not just a carrier of instructions but a record of history. Our genomes contain traces of ancient viruses, fragments of long-extinct ancestors, echoes of migrations across continents. Life writes, edits, and rewrites itself over time, leaving a palimpsest of survival. If you imagine a civilization encoding intention into that medium, then every cell becomes both organism and archive. A message doesn't need to be read consciously, it only needs to continue. There's an uncanny charm in thinking of Earth itself as part of such correspondence. Our forests, our oceans, even our own bodies, could be considered the unfolding paragraphs of a story begun long ago, a letter whose first line was penned by hands or forces unseen. Perhaps every planet that blooms with life is another page in a cosmic diary scattered across the stars. Not everyone agrees, of course. Some scientists caution against layering intent where there is only chemistry. To them, life's persistence is explanation enough, no sender required. Yet others counter that communication is always about persistence, about leaving something behind that endures beyond the speaker. By that measure, life is the most eloquent message of all. And so, when you think of 3i Atlas, you no longer see only a cold stone slipping by. You begin to imagine it as a letter sealed in ice, its meaning waiting not to be decoded but to be lived. Picture it, an object cast from a star system long forgotten, sailing across the void without destination, carrying only the possibility of awakening elsewhere. No beacon flashes, no antenna broadcasts, no encryption waits to be cracked. The message is simpler, deeper, life itself, entrusted to the currents of space. On Earth, we already know how subtle messages can be. A seashell records the rhythm of tides from millions of years ago. A tree's rings archive decades of climate, drought, and rain. Fossils whisper across epochs, telling us who walked before us. If natural processes can hold and deliver meaning without intention, then a vessel like 3i Atlas, whether crafted or accidental, could magnify that same principle on a galactic scale. There is even something poetic in the silence. A written note requires language. A radio pulse demands a shared frequency. But life is universal in its own way. No matter the form it takes, whether carbon-based like ours or woven from stranger chemistries, life announces itself through action, replication, adaptation, survival. If you find life, you know someone has spoken, even if you cannot trace the voice. Of course, silence can also be unsettling. If these objects are messages, why do we not receive them more clearly? Why not something unmistakable, undeniable? Perhaps the answer lies in patience. A stone takes eons to deliver its words. A seed takes millennia to grow into something recognizably alive. The timing is not for us, it is for the universe. We are simply fortunate enough to glimpse the letter while it passes by. So you lie back with the thought that 3i Atlas might be more than a comet, more than a curiosity. It could be a whisper across cosmic distances, a message entrusted not to fragile radio waves but to the tenacity of biology, a silent message cast into the dark, trusting that somewhere, someday, it will be opened not with eyes, but with life itself. And as that thought settles, the next question rises almost naturally. If such a courier does carry seeds and stories, could those gifts be safe, or might they also hold dangers we cannot yet foresee? Up to now, the thought of 3i Atlas as a seed ship has felt almost tender, a courier of life, a frozen ark, a letter written in biology. But the moment you linger on that vision, another possibility creeps in like a chill draft under the door. What if the cargo is not a gift, but a threat? On Earth, we've seen how fragile ecosystems can be. Introduce a new species into the wrong place, and the balance shatters. Rabbits released in Australia multiplied until they consumed the land. Cane toads brought in to fight pests instead became a pest themselves. Viruses that leap from one species to another can devastate entire populations, rewriting lives in weeks. If such upheavals can be sparked within a single planet, what might happen if seeds from another star landed here? The science of it is both fascinating and sobering. We know microbes can survive in hostile environments. Some bacteria repair their DNA even after heavy radiation. Others endure frozen sleep for tens of thousands of years. This resilience is exactly what makes panspermia possible and what makes it dangerous. A single alien microbe, if awakened, might interact with our biology in ways we cannot predict. It might be harmless, unable to survive here. Or it might find Earth's chemistry not only compatible but vulnerable. There are stories whispered among astrobiologists, half cautionary tale, half speculation. What if the first true alien life we encounter is not a signal or a spacecraft, but a spore hidden in ice? Something invisible to the naked eye, small enough to ride on dust, yet potent enough to alter ecosystems forever. It would not announce itself with lights in the sky, but with symptoms, mutations, collapses we cannot yet imagine. Debates flare over this risk. Some argue that alien microbes would almost certainly be incompatible with Earth's life, their biochemistry too different to interact meaningfully. Others counter that unpredictability as precisely the danger. Even a small overlap could open the door to havoc. Between those poles lies a wide field of unease, where imagination fills the gaps with both nightmares and warnings. And so the seed ship becomes more ambiguous. A courier of hope, yes, but also a potential Trojan horse drifting silently through the dark. Picture the moment of contact. A fragment of 3i Atlas plunges through an alien atmosphere, shattering on the surface below. Dust and vapor scatter, and in that cloud may lie organisms or molecular machines older than our solar system. If even a few survive the fall, they could find themselves surrounded by conditions utterly unfamiliar, new minerals, new chemistries, new opportunities. History on Earth shows us how often newcomers thrive in ways the natives never expected. Kudzu vines, carried from Asia to the American South, smothered fields and forests. Zebra mussels, hitching rides in ship ballast, colonized lakes across North America, clogging pipes and displacing native species. These examples are not alien in origin, yet they remind us of a hard truth. When life crosses boundaries, chaos often follows. Biologists sometimes joke that microbes are the true rulers of Earth. They outnumber us, outadapt us, and survive disasters that would erase every larger creature. If a microbe from elsewhere shared even a fragment of common ground with our biology, it might spread with breathtaking speed. And unlike an invasive plant or animal, we would have no evolutionary history with which to resist it. Of course, the opposite is also possible. The alien seeds might fail immediately, their chemistry too foreign to metabolize Earth's sugars or proteins. They might lie inert, unnoticed, unable to bridge the gap between their world and ours. Some researchers even argue this is the most likely outcome, that incompatibility is our shield. Yet no one can guarantee it, and in that uncertainty lies the unease. The idea has even inspired fiction and cautionary studies. Some have suggested that strict quarantine procedures would be essential if we ever captured material from an interstellar visitor. The prospect of xenopathogens, diseases from beyond, has been taken seriously enough to appear in NASA protocols, even if only as precaution. Better to over-prepare than to be surprised. So as you watch 3i Atlas slip past in your imagination, its silent presence carries not only wonder but also warning. The ark may cradle seeds of life, but not all seeds bloom into beauty. Some sprout thorns. Let your imagination run further. Suppose one of those hidden passengers is hardy enough to awaken here. At first it goes unnoticed, a curiosity in a lab sample or a faint anomaly in soil chemistry. Then it begins to replicate, fast and silent, moving through niches we never considered vulnerable. A new growth in oceans, a new pattern in crops, a new illness in lungs. The message of life becomes distorted, arriving not as kinship but as calamity. Earth's history is already marked by upheavals on smaller scales. Viruses leaping from animals to humans have reshaped societies time and again. Entire species have vanished because of fungi carried unknowingly from one continent to another. Amphibians, bats, even trees have been driven to the edge by pathogens they never evolved alongside. If such devastation can be unleashed by earthly organisms simply crossing local borders, the arrival of something wholly alien feels both terrifying and strangely plausible. Yet even here, the debate endures. Many scientists hold that alien biology would be too alien, its molecular machinery so unlike ours that contact would fizzle, not flourish. DNA might not even be its language, proteins not its tools. The gulf could be unbridgeable, protecting us by sheer difference. Others argue that chemistry is universal, that carbon chains and sugars appear throughout the cosmos, and with them the possibility of overlap. That narrow overlap is all any parasite needs. This is why every idea of a seed ship carries a double edge. On one side, the beauty of life scattered like stars, promising gardens where there were once only deserts. On the other, the shadow of contamination, the nightmare that what blooms is not a forest but a plague. Each possibility is bound into the same package, inseparable, like twin seeds hidden in one shell. And so, as 3i Atlas drifts past in silence, you are left with the same tension astronomers and dreamers feel, awe at its mystery, unease at its potential. A courier can carry letters of love or weapons of war. Until the envelope is opened, you cannot know which it island. The thought lingers as a soft warning. Every gift carries risk, every seed carries uncertainty, and with that, your mind naturally turns to those who watch our skies, not only to study, but to guard. After letting the unease of hidden risks settle, your thoughts turn naturally toward the watchers, the quiet guardians who stand between our planet and the dark. 3i Atlas is a wonder to imagine, but to astronomers and planetary defense teams, it is also a responsibility. Every object that drifts close enough to Earth must be tracked, measured, understood, not just to unlock its secrets, but to ensure it poses no danger to the fragile world below. High above deserts and mountaintops, telescopes sweep the night sky, logging thousands of streaks of light. Most are familiar asteroids catalogued long ago, comets on predictable returns, satellites glinting as they pass, but every now and then the numbers refuse to fit. A trajectory bends too steeply, a velocity is too fast, a visitor like 3i Atlas reveals itself in the data. When that happens, curiosity sharpens into vigilance. Science has already shown us why such vigilance matters. In 2013, a meteor exploded over Chelyabinsk, Russia, with the force of dozens of nuclear weapons, shattering windows across a city and injuring more than 1,000 people. That rock was only about 20 meters across. Far larger impacts dot Earth's history, from the crater in Arizona to the one in Mexico's Yucatan, linked to the dinosaurs' extinction. Our planet has always been vulnerable, and will always be, unless we remain alert. There's something quietly noble about the way this work is done. No dramatic music, no movie heroes, just teams of scientists running nightly surveys, scanning petabytes of sky images, cataloguing what passes above us. Their goal is simple but monumental, to make sure nothing catches humanity by surprise. They are gardeners of a different kind, not planting seeds but pruning threats. And still, among the calculations and simulations, the mystery remains. Because while the job is protection, the act of watching often delivers wonder too. To catch an interstellar visitor is to be reminded that we are not alone in the galaxy's flow of debris, that the space between stars has its own traffic. Guardianship becomes curiosity, and curiosity circles back to guardianship. Think of the infrastructure quietly in place to keep watch. Across the globe, observatories like Pan-STARRS in Hawaii, the Catalina Sky Survey in Arizona, and the forthcoming Vera Rubin Observatory in Chile scan the heavens with relentless precision. Their cameras sweep vast swaths of sky every night, capturing thousands of moving points of light. Algorithms then compare these images, teasing out the ones that behave oddly, objects whose orbits cross Earth's path, or whose speed suggests interstellar origins. When 3I Atlas was first noticed, it was these same networks of vigilant eyes that caught it. To most people, it was just a designation in a database, but to those who monitor the sky, it was a guess that required attention. They knew immediately it posed no danger to Earth, its trajectory carrying it past at a respectful distance. Still, it was logged, measured, and followed, because even a harmless visitor tells us something about the environment we inhabit. The parallel is striking. Just as biologists keep seed banks and genetic libraries to safeguard life against disaster, astronomers keep a celestial inventory to safeguard Earth against collisions. One catalogue preserves our beginnings, the other guards our future. Both are acts of stewardship, born of the knowledge that fragility is part of existence. And it isn't only passive watching. Engineers and scientists are actively rehearsing what to do if something larger, more threatening, is discovered. In 2022, NASA's DART mission deliberately slammed a spacecraft into the asteroid Dimorphos, nudging its orbit ever so slightly. It was the first test of planetary defense, a small but historic proof that humanity could, if needed, alter the course of a rock hurtling our way. It's a reminder that guardianship isn't only about seeing, it's about readiness. Still, even as we prepare, questions linger. Can every threat be detected in time? Would we always have the means to respond? And what if a visitor isn't just rock and ice, but something stranger, like the seed ship we imagine 3I Atlas might be? Guardianship may need to extend beyond physics into realms we have not yet dared to plan for. Picture the quiet rhythm of this guardianship. Every night, while cities sleep, telescopes pivot across the sky, their mirrors polished to catch even the faintest streak of light. Data streams to servers, algorithms sift patterns, and human eyes review anomalies. Most nights yield nothing more than the endless traffic of asteroids, satellites, and cosmic dust. But that nothing is itself an achievement. Another night in which Earth spins safely under its watchful canopy. To the scientists who do this work, vigilance is rarely dramatic. It is patience and persistence, like a lighthouse keeper trimming the wick of a lamp, ensuring it never goes dark. They know that sooner or later, another visitor will arrive. It might be harmless, like 3I Atlas, or it might be a rock large enough to scar continents. In either case, someone will be awake to notice. There is something profoundly human in this act of watchfulness. We are fragile creatures on a fragile world, yet instead of turning away from the vastness, we choose to look straight at it, to name what passes, to prepare for what might come. Guardianship is not only about fear, it is about respect. To live beneath a sky full of wanderers is to acknowledge our vulnerability, but also our capacity to meet that vulnerability with care. Of course, debates ripple even here. Some argue we are not ready, that funding and technology lag behind the scale of the threat. Others believe we are on the cusp of true preparedness, with new observatories and defense tests laying the foundation. Between those views lies a balance, much like the one in your own thoughts tonight. Caution tempered with wonder, vigilance softened by curiosity. So when you think of 3I Atlas in this light, it becomes more than a curiosity from afar. It is also a reminder of the unseen guardians keeping watch, scanning the skies not just for science, but for safety. Their work hums quietly beneath the noise of the world, like a heartbeat that rarely draws attention until it falters. And for now, that heartbeat is steady, keeping time with the stars above. Even with guardianship in place, with telescopes tracking and scientists measuring, the imagination slips through the cracks. Numbers tell us that 3I Atlas is just a fragment of ice and stone, but whispers collect in the quiet corners of thought. What if it is more? What if its passing is not accident, but design? For centuries, humanity has been drawn to fringe possibilities, not out of gullibility, but out of curiosity. Myths speak of gods sending signs in the heavens. Science fiction spins tales of probes disguised as comets, sowing life across the galaxy like a farmer scattering seeds. Some thinkers even wonder aloud if our reality itself could be part of an experiment, with visitors like 3i Atlas acting as instruments in a larger hidden program. There is, of course, no proof, and yet the absence of proof has never silenced the imagination. Instead, it gives room for speculation to breathe. Perhaps these travellers are not random debris, but carefully placed couriers. Perhaps each one is a test Oumuamua, Borisov, now Atlas, all drifting past within a handful of years, as if following a schedule we do not yet understand. Science adds fuel in subtle ways. Consider the Voyager spacecraft we have sent outward. Each carries a golden record, etched with greetings, maps, and music. We know those records will likely never be found, but we sent them anyway, hoping that if they were discovered, they would stand as proof that we once looked outward. If we are willing to do that after only a century of spaceflight, what might a civilization millions of years older attempt? Their probes would not be fragile machines, but durable stones, built to last and to blend into the landscape of comets. Of course, skeptics laugh at such ideas, pointing out that extraordinary claims require extraordinary evidence, and no such evidence exists. Yet even in their laughter, the whisper persists. It is the whisper that says, just because something looks ordinary does not mean it island. And so, as you picture 3i Atlas gliding away, you wonder, is it only a shard of elsewhere, or is it a device carrying intentions we cannot yet read? Let the speculation drift a little further. Imagine that what appears to us as randomness, the ejection of comets, the scattering of icy bodies might, in some cases, be deliberate. A civilization wishing to seed the galaxy might not build ships bristling with engines. They might use nature's own vessels, embedding instructions or organisms within chunks of ice and stone, then letting gravity and time deliver them like messages in bottles. The disguise would be flawless. Who would suspect a comet? On Earth, we have already begun small echoes of such thinking. Scientists have talked about sending capsules filled with microbes to other planets as a way to study survival in extreme conditions. In laboratories, tiny organisms called tardigrades have been placed on the outside of spacecraft to test their resilience. Some even survived the harsh vacuum of space, clinging to life after conditions that would erase larger creatures instantly. These are not missions to conquer or colonize, but experiments, curious probes testing the boundaries of biology. From this perspective, it is tempting to wonder whether 3i Atlas could be part of something similar on a far grander scale. Perhaps not a lone wanderer, but one of countless test objects released into the galaxy. Some would fail, others would crash on barren rock, but a few, just a few, might find soil, water, and the chance to awaken. There are thinkers who even stretch the idea further, suggesting that what we call the evolution of life may itself be data from such experiments. Each planet seeded, each species rising and falling, could be a kind of cosmic laboratory, its results observed silently from afar. It is an unsettling vision, one that makes existence itself feel like a test whose purpose we do not know. And yet, as wild as the idea sounds, it fits neatly into a long human tradition of asking, what if we are not alone, and what if our role is smaller or stranger than we thought? Even if no evidence exists, the story lingers, because the unknown has always been fertile ground for whispers. The more you follow this line of thought, the stranger it becomes, and the more strangely comforting too. What if our galaxy is not just a wilderness but a garden under quiet cultivation? Perhaps arks like 3i Atlas are not anomalies but instruments, drifting along preordained paths, scattering their contents according to a design we can barely glimpse. There is precedent, at least in metaphor. Bees do not know the full scope of the garden they pollinate. They move from flower to flower, unaware of the broader beauty they help sustain. In the same way, comets and asteroids might be buzzing pollinators of the cosmic field, carrying genetic pollen from star to star. Whether guided by intelligence or by some deeper natural law, the effect would be the same: life spreading through quiet repetition, planet by planet, age by age. But questions stir uneasily. If these objects are deliberate, who set them in motion? Were they sent by civilizations unimaginably older than ours, now vanished into their own ruins? Or are they still watching, far away, tracing the outcomes of seeds they scattered before humanity even existed? Some theorists go so far as to suggest that our very curiosity, the way we wonder about these things, might itself be part of the design, a built-in response to ensure the seeds continue asking about their gardeners. Others dismiss such thoughts as fanciful embroidery on ordinary physics. To them, 3i Atlas is just a rock, and our need to weave meaning around it says more about us than about the object itself. Yet this tension, the pull between skepticism and possibility, has always been where human imagination thrives. So you let the whispers remain. They do not demand answers, nor proof, nor even belief. They are simply the hum beneath the silence, the half-heard murmur that turns a passing comet into something more, a device, a seed, a test, or a story. Whatever the truth, the whisper changes the way you see the night, and that may be its only purpose. And as the whisper fades, another picture begins to form, not of secrecy, but of beauty, the thought of a universe as a garden, and seed ships like 3i Atlas as grains scattered to the winds. Let the whispers fade, and in their place a softer image unfolds, one less about secrecy, more about beauty. The universe begins to look not like a cold expanse of emptiness, but like a boundless garden. Every star a flower, every nebula a fertile patch of soil, every seed ship a grain scattered on the wind. 3i Atlas is only one among countless others, drifting like pollen across the night. It is not difficult to see why this image appeals. We have always loved gardens. From the hanging terraces of Babylon to the neat rows of village plots, gardens are our way of shaping chaos into meaning. They remind us that life can flourish when tended, that beauty arises from patience. To picture the cosmos as such, a place is to imagine that existence itself is nurtured, not accidental. Science lends its quiet nod here too. Astronomers now know that planets are common, not rare. The Kepler mission revealed that nearly every star may host worlds, some rocky, some watery, some even sitting in that delicate, habitable zone where liquid water could pool. If stars are flowers, then planets are surely their soil, and what gardener could resist sprinkling seeds widely, trusting some to take root? On Earth, the metaphor becomes tangible. Every spring, winds scatter seeds across landscapes, most falling on stone, a few finding crevices rich enough to grow. The success of a single sprout among millions is enough to green entire valleys over time. By scale alone, the galaxy promises the same. With trillions of seeds, even the slimmest chance becomes inevitable somewhere. Of course, skeptics remind us that beauty can deceive. The universe is harsh, full of radiation, vacuum, and endless gulfs of space. Many seeds will never bloom, lost in silence. But gardens are never without failure. For every seed that thrives, countless others vanish unnoticed. What matters is that enough survive to keep the cycle alive. And so, you let yourself imagine the cosmos as a living tapestry, where each seed ship, like 3i Atlas, is part of a greater design. Not a mistake, not a threat, but a contribution to something vast and ongoing, the quiet cultivation of life across the stars. Let your imagination wander further into this garden. Stars are not silent dots anymore, they are trees, towering and radiant, each one dropping its seeds into the dark. Comets arc like drifting dandelion fluff, spreading fragile possibilities across invisible currents. Nebulae bloom like fields of wildflowers, their colours vivid in telescopes, their gases dense enough to cradle the chemistry of beginnings. The cosmos becomes less a void than a landscape in perpetual spring. Science echoes this vision in its own language. We now know that many of the elements essential to life, carbon, nitrogen, oxygen, are forged in the hearts of stars and scattered when those stars die. Every breath you take is threaded with material that once burned in stellar furnaces. If the galaxy is a garden, then stars are not only flowers but also composters, enriching the soil with their own remains. Life, in this sense, is not separate from the garden but born directly from it. There's also a peculiar comfort in realizing how wasteful nature can be. A tree produces thousands of seeds each year, though only a handful ever grow. A garden thrives not because every seed succeeds, but because enough do. In the same way, a universe filled with seed ships like 3i Atlas does not require each one to find a home. It only requires that a few survive the long night. That alone is sufficient to transform silence into song. Skeptics insist that this is just metaphor layered onto randomness. To them, comets and asteroids are not gardeners, merely debris, but metaphors themselves can shape understanding. Seeing the universe as a garden invites us to notice the patterns of abundance, resilience, and renewal already present in its design. It softens the vastness, turning an intimidating void into something almost familiar. And so, lying under the quiet sky, you begin to see yourself not as an outsider looking in, but as part of the garden itself. You are both seed and soil, product and participant, a continuation of the same scattering that sends stones across space. Stay with the vision a moment longer. The night above no longer feels empty but alive, humming with the slow work of cultivation. Each arc of a comet, each collision of asteroids, each drifting fragment like 3i Atlas becomes part of the quiet tending of this cosmic soil. You can almost hear the hush of it, like wind moving through grass too tall to see the end of. On Earth, gardens are places of patience. A gardener plants not for today, but for seasons to come. Seeds are covered, forgotten, only to reappear transformed. In the same way, the universe does not rush. Its seasons are measured in millions of years. Its harvests are not stalks of grain, but oceans, forests, and beings who lift their eyes to wonder how it all began. There's a wonder in realizing that we ourselves may be blossoms of this larger garden. Our DNA, our thoughts, even our questions could be the flowering of a seed sown long before Earth itself solidified. If that is true, then when we imagine seed ships drifting across galaxies, we are really imagining our own ancestry scattered wide, rooting wherever chance allows. Of course, no one can prove this vision. Scientists debate whether panspermia is anything more than an elegant speculation. Some argue that life arose independently here, with no need for distant gardeners. Others allow that the evidence of organic molecules in comets and meteorites keeps the possibility alive. And so the debate itself becomes part of the garden too, fertile ground for wonder, whether or not certainty ever arrives. As you let the thoughts settle, the stars above shift again. They are no longer remote lights, but lanterns glowing in a vast orchard, marking rows of worlds where seeds may already be stirring unseen. And in that orchard, 3i Atlas is just one wandering messenger, a single grain of possibility among countless others. The garden continues, whether or not we notice, whether or not we understand, and in its quiet unfolding, it invites you to feel less alone, because to live at all is to already be part of its bloom. The journey of 3i Atlas winds slowly toward its close in your mind, and you find yourself returning, almost instinctively, to something familiar, the glow of the moon. It has been hanging above us all along, steady and bright, watching silently as we wove stories of seed ships and cosmic gardens. No matter how far our imagination drifts, the moon is always there, reminding us that wonder is not only out in the unreachable dark, but also here, lighting the night you live under. Picture yourself gazing at it now. Its surface, pitted and scarred by ages of collisions, reflects sunlight softly onto your window. You know the craters tell tales of impacts much like the ones we imagined for distant worlds, proof that seeds of stone have been falling here for billions of years. The moon itself is a kind of archive, a witness to the long traffic of the cosmos. The science confirms this. Lunar samples brought back by Apollo missions contain tiny fragments of meteorites, captured and preserved in the regolith. Some of those rocks carry traces of organics, simple building blocks that likely came from comets. Even our closest celestial neighbour holds whispers of the garden. We spoke of motes of chemistry delivered across eons, tucked into its soil like forgotten notes. And then, a thought as gentle as moonlight itself. When you look at the moon, you are sharing a view that every human across history has known. Ancient poets, explorers at sea, Children in fields all saw the same glow. And now, perhaps, a seed ship like 3i Atlas is drifting nearby in the same sky, unseen but present, carrying its secret cargo past the silver lantern we know so well. It feels almost like an invisible kinship. The moon, the traveller, and you each caught in the same web of night, bound by light and gravity, each whispering your existence simply by being here. Let your imagination drift outward from the moon, carrying your gaze across the dark gulf between here and the stars. Somewhere out there, perhaps only a faint glimmer beyond our reach, 3i Atlas glides silently, keeping pace with our solar system for a brief moment before it slips away again. You cannot see it, yet knowing it exists reshapes the sky. The moon becomes not only a companion of Earth, but a lantern shining over a meeting place between the familiar and the unknown. This overlap of nearness and distance has always moved human hearts. In ancient times, the moon was woven into myths, goddesses carrying torches, rabbits pounding rice cakes, faces watching us while we slept. Now, science offers a different but equally haunting truth. The moon stabilizes our planet's tilt, holds sway over our tides, and quietly keeps our world livable. It is both symbol and mechanism, story and science. And tonight, it shares its domain with an interstellar visitor. Think of the contrast. The moon has circled Earth for billions of years, steady as a metronome. 3i Atlas, by comparison, will pass only once, never to return. One is permanence, the other fleetingness, yet both are bound together in your view of the sky. The steady glow and the unseen traveller, together forming a reminder that the universe holds both continuity and surprise. There's a poetic tidbit here too. Lunar light, soft on your face as you imagine this, is ancient sunlight reflected back to you. Some of those very photons left the sun minutes ago, bounced off the moon's surface, and now illuminate your night. At the same time, 3i Atlas is reflecting sunlight too, though across much greater distance, scattering faint rays no eye can pick up. Two mirrors in the dark, one close, one far, both carrying the same light. And perhaps that is the truest message. Everything is joined by light, even the most distant seed ship and the moon you've known since childhood. Stay with the scene a little longer. The moon hangs steady, glowing softly against the black, while somewhere unseen a shard from another star system continues its brief passage. Both are reminders of time, one measured in eons of repetition, the other in a fleeting brush with our awareness. And you, caught between them, become the witness to their silent companionship. The scientific mind might point out that the odds of any interstellar object passing near Earth during our lifetimes are slim, and that noticing even one is extraordinary. Yet the dreamer's mind responds differently. Slim odds do not diminish wonder, they magnify it. The coincidence of looking up at the moon while knowing such a traveller is out there transforms the ordinary night into a shared moment with the cosmos. Think of it as a quiet conversation. The moon whispers stability, the promise of tides and rhythms that have guided life since its beginning. The traveller whispers possibility, carrying hints of stories from stars beyond our own. Between the two, you hear the same refrain. Life is fragile, yet it endures. It is local, yet it may also be universal. Skeptics might dismiss such thoughts as poetry, but poetry has always been humanity's way of holding truths too wide for equations alone. Science can measure orbits and ages, but only imagination can draw the thread that ties you, the moon, and a nameless seed drifting through space into a single tapestry. So tonight, when you look at the moon, whether through a window pane, from a city balcony, or lying in the grass of a quiet field, let the thought settle in you. Under this same moonlight, somewhere out there, 3i Atlas is gliding silently, carrying its secrets, its risks, its wonders. You may never see it with your own eyes, but its presence changes the way you see everything else. And with that realization, the story arcs gently toward its pause, the garden, the ark, the silent message, the hidden risk, all threads now woven together under the glow of the same moon. The story has carried you far tonight through frozen arks, silent couriers, whispers of the unknown, and gardens scattered across the stars. But now the pace slows, As gently as a tide retreating from the shore, the images soften, edges blur, and what remains is not the need to understand, but the comfort of resting inside the mystery. Close your eyes for a moment and imagine the night sky above you. The moon is there, steady as ever, its silver glow smoothing the world below. Somewhere beyond, unseen but still real, a traveller like Three-Eye Atlas drifts farther into the dark. You do not need to follow it anymore. It knows its path, and you know yours, to rest, to breathe, to let your mind loosen. The details you heard tonight about DNA and ice, microbes waking after centuries, telescopes guarding the heavens no longer need to be sharp in your memory. They can dissolve like footprints in sand. What stays behind is simpler, the sense that you are part of something vast and ongoing, a garden wider than galaxies, tended by time itself. Feel how quiet the room is around you. The hum of your own breath becomes the only rhythm you need. In that rhythm, you can almost sense the same patience that keeps a seed alive in the dark, waiting for spring. You are that seed tonight, protected, resting, storing energy for the day when you will wake again. If stray thoughts come, let them drift past like meteors across the sky. Notice them, then let them fade, leaving only the background glow of stillness. There is no need to hold on, no need to solve, no need to reach. The story is finished, and now you are free to let go. You are lying under the same moon that countless generations have looked upon. You are breathing air shaped by oceans, forests, and distant stars. You are part of the same unfolding that may have begun with a wandering seed ship long before Earth ever had a name. Let that thought cradle you. You are not separate from the cosmos, you are woven into it. Every heartbeat is in time with the universe. Every breath is starlight made gentle. And now, as your eyes grow heavier, picture yourself drifting too, not through stress or effort, but through calm currents that carry you exactly where you need to be. The vastness above is not something to fear. It is an endless sea of quiet, and tonight it welcomes you to float within it. Rest in that sea of stars. Rest knowing the guardians keep watch, the seeds keep waiting, the moon keeps shining, and you are safe beneath it all. Sleep well, traveller. The universe will still be here when you wake,